Hey everyone, I am Amber from Group 2 and for today, we will talk about the chemical reactions in the ozone layer in our stratosphere. It will be explained to us by Lemmer and Jeline. Go guys!
Hello guys, I'm Lemma. Today I'm going to tell you guys about chemical reactions that form the ozone layer in the stratosphere. To start, stratostropic ozone is formed naturally by chemical reactions involving solar, ultraviolet, radiation, and oxygen molecules, which make up to 20% of the atmosphere. In the first step, ultraviolet radiation breaks apart one oxygen molecules to produce two oxygen atoms. Then each of these hydroreactive atoms combines with an oxygen molecule to produce an ozone molecule. These reactions occur continually whenever solar ultraviolet radiation is presented in the stratosphere. As a result, the largest ozone production occurs in the tropical stratosphere. Ozone reacts continually with sunlight and a wide variety of natural and human-produced chemicals in the stratosphere, in which reaction the ozone molecule lost and other chemical compounds are produced. Important reactive gases that destroys ozones are hydrogen and nitrogen oxides and those containing chlorine and bromine.
Hi everyone, I'm Jeline. Now we will go ahead and talk about the benefits and harms we can obtain from it. First, let us know the benefits. The main benefits is it protects the Earth from harmful ultraviolet rays from the sun. Without the ozone layer in the atmosphere, life on Earth will be very difficult. Plants cannot live and grow in healthy ultraviolet radiation, nor can the plankton that serve as food from the most in the ocean life. Now we are done with the benefits. Let us now explore the harmful effect. Ozone layer depletion causes increased UV radiation levels at the Earth's surface, which is damaging the human health. Negative effect includes increased the certain types of skin cancer, eye cataracts, and immune deficiency disorder.
Now that we know its benefits and its harmful effects, let us watch this video for more information.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.